Good day, everyone. Welcome to our new episode of Practice Problems. This will be the last part for patterns and sequences. And we're now dealing with word problems. So let's start. Now, for the instruction, answer the following word problems. First in our problems is this. What is the third term of the sequence whose general term is a sub n is equal to 2n raised to 2n? So, this kind of problem, all we need to do is to find the third term. So find the third term. So in that case, in other words, we are asked to find a sub 3. Now to find a sub 3, all we have to do is substitute 3 to the values to the variable n. So to do that, let's just do this. Okay, as you can see, I just substitute 3 to the values of to the variable n. So now we have the if we're going to evaluate that, we will do it first here. We need to evaluate this first. So that would become 2 times 3 is 6. Now 3 raised to 6. 3 raised to 6. That would be 729. Now 729 times 2, that would be 1,458. So that is our third term. That's the answer for this question. For number 2, uh, verify if 78 is a member of the sequence whose general term is a sub n is equal to n squared minus 2. In this question, we are asked if whether 78 is a member of this term. Meaning, if we're going to plug the number of term here, can we get 78? So to answer that, let's assume that 78 is a member of this general term. So let's substitute 78 to the a sub n because that's the term that we're looking for. If the value of n here is positive integer, then there are positive integer or counting number, then therefore 78 is a member of this sequence. But if we get a decimal, a fraction, or a negative number, then therefore it is not. So now let's try to add 3 on both sides. So that would cancel this, and this will become 81. So we have n squared is equal to 81. Now let's get the root of both sides. What is the square root of 81 and what is the square root of n squared? So the square root of 81 n squared is 9 and n. So meaning the value of n is equal to 9. If if the value of n is a positive integers or positive or counting numbers, then therefore 78 is a member of that sequence. Now let's check to make sure if the ninth term is 78. Now let's substitute 9 to n. So we have this. The 9 raised to 2 is 81. 81 minus 3 is 78. So yes, 78 is a member of the sequence. A sub n is equal to n squared minus 3. For problem number 3, find the first three multiples of 6, and find the general term of the sequence. Okay, as this is basic, the first three multiples of 6 are 6, 12, and 18. So that would be our a sub 1, a sub 2. Now to know the general term for this, meaning the formula, all we have to do is to check if it has a common difference at first try. So our common difference is 6 on first try. So let's use a sub n is equal to 6n. Okay. Now, because let's check if this initial formula is our general term. So let's substitute 1, 2, and 3 to the value of n to see if we can get 6, 12, and 18. So in this case, um, the value of a sub 1, a sub 2, a sub 3 is 6, 12, and 18. It is similar to the first three multiples. So therefore, The general term is a sub n is equal to 6n. If you want more about this kind of problems, just visit my previous tutorial about getting the general term of a sequence. It's also under patterns and sequences. Problem number 4. Find the 10th term of the sequence 8, 15, 26, 41. Now to answer this, all we can do it manually. So by writing the sequence and putting next putting a line or a blank next to it until it comes to the 10th term because we're asked to find the 10th term. Now let's see on first try if it has a common difference. So 15 minus 8, that is 7. 26 minus 15, that is 11. 41 minus 26, that is 15. So as you can see, there is no pattern yet that emerged. Let's check first. Let's check again if it has a common difference on our second try. So we have 11 minus 7 is 4. 15 minus 11 is 4 as well. So all we need to do is to add 4 in it and we plus the sum to to the last term to get the next term. So let's try to complete our diagram. Okay. Now the pattern is 4. 15 plus 4 is 19. 19 plus 4 is 23. 23 plus 4 is 27. 27 plus 4 is 31. Then 31 plus 4 is 35. Then 35 plus 4 is 39. Now let's see. 41 plus 19. So that is 60. 60 plus 23. So that is 83. 83 plus 27. That is 110. 110 plus 31. That is 141. 141 plus 35. That is 176. Then 176 plus 39, that is 215. So this is our 10th term. This is tedious and it needs a lot of work, but but you'll be sure that of your answer because of this kind of technique. But now, if you want, we could use the lesson or a previous lesson, a previous problem practice problem tutorial, we do get it by means of this. Again, if I choose it on the first glance, at first time, I get 7, 11, and 15 as the difference. And I get the 4 as difference of the first difference. So therefore, we will treat this sequence as as a quadratic. So we need to divide 4 by 2 to get 2. Then we will use this formula. We will use this 2 to substitute on A because that would be the value of A. Now let's try to do it first. And let's plug in the formula to see, find the first 4 terms to see if it will correspond to our first 4 terms. So we have that. So as you can see, we cannot get 8 on our first term and 15 on our second term. So we need to adjust it. Now, after trial and error, you can see that if we going to add this, we can get 8 if we add 1 and 5, 2 and 5, 3 and 5, and 4 and 5. So in that case, we can change this one as n to be our formula. So we have this. So our formula now is a sub n is equal to 2n squared plus n plus 5. Now let's get the 10 term. Let's substitute 10 to n. So we get this, and 2 times 100 is 200. 200 plus 10 plus 5, and that would be 200. So on both ways, we get 215. So therefore, the 10th term of this sequence is 215. Now problem number 5. What is the first term of the sequence 36, 18, 9, and so on, that is less than 1. Now, this is somehow confusing, but this is a geometric sequence. Later on the next practice problems, we're going to encounter that kind of sequence. So in this case, let's just write it like this and see what is the first term that is less than 1. So it could be, this is 1, 0, wait, this is negative 1, 0, and 1. This is the number line. So less than 1 are here to here. So that is 0.99 below. So we're looking for that term. So as you can see, the pattern here is you need to multiply 1/2 to get the next term. 36 times 1/2, or 36 divided by 2 is 18. 18 times 1/2 is 9. Now the next term is 9 times 1/2 is 9 over 2. Now 9 times 1/2 again, that would be 9 over 2 times 1/2. Numerator to numerator, that is 9 over 4. It's 9 over 4. 9 over 4 times 1/2 again, that would be 9 over 8. 9 over 8. If we divide 9 over 8, we have 1 point something. So that is not less than 1 yet. Now let's multiply it again by 1/2. That would be 9 over 16. So 9 over 16. Now if you use your calculator and if you divide 9 divided by 16, you will know that this is between 0 and 1. So this is less than 1. So our answer is 9 over 16. Now let's go to problem number 6. This will be our last problem. Find the general term of the sequence 1, 4 over 5, 6 over 10, 8 over 20. Now all we have to do first is to transform all of the sequence into simplest form. So we have 4 over 5. Now 6 and 10 are both divisible by 2. 6 divided by 2 is 3. Then this one is 5. On number 8, 8 is divisible as well by 4 and 20 is divisible by 4. So 8 divided by 4 is 2 and 20 divided by 4 is 5. As you can see, we have 5 as our common denominator. Now let's change 1 into a denominator of 5. So that would be 5 over 5. So we have this sequence. Now all we need to do is to come up with a formula that will give us this. So let's try writing a sub n is equal to, we know 5 is constant, so we need 5 uh, uh, on the denominator. So if I'm going to get um, this 5 at the numerator, I will just use I'll just use 1 because that is the value of our n. So what are we going to do to 1 to make it positive 5? So I will add 4. So 1 plus 4 is 5. So 5 divided by 5 is 1. But take note, if we're going to change it into 2, can we get the second term? Okay, so 2, let's try this, a sub 2 is equal to 2 plus 4 over 5. 2 plus 4 is 6 over 5. So that is different from our second term because our second term is 4 over 5. Now let's try another one. Let me erase this first. We know that our AR formula should be a sub n is equal to something over 5 because 5 is constant. So what are we going to do next is to think of a number of what we're going to do to n to make it 5. Imagine n is 1. So all you have to do is, we try positive a while ago, so let's try to put 6 first. So we have 6, So what we're going to do with 6 and then minus n, because n is 1. So we try 6 minus 1 is 5, 6 minus 2 is 4, 6 minus 3 is, 6 minus 2, 3 is 3, 6 minus 2 is, 6 minus 4 is 2. So now we came up with this formula. So this is the answer for this problem. Or this one, negative n plus 6. Or it could be 6 minus n. Either or will do. So that's all for just this tutorial. I hope that you learned some techniques on how to answer word problems under the topic of patterns and sequences. Now watch out for the next episode about arithmetic sequence. So that's all for today. Goodbye and thank you.